Hello everyone, welcome to the Cat East Tech YouTube channel, and this is the third video for Orcad cadence tutorials. FYI, cadence is the name of company and Orcad is the name of software. Also, there are a lot of sub-softwares under Orcad, but we are dealing with Pspice. And today I made a small representation for you guys, and I will explain a little bit about Pspice. And let's get started. Okay, Pspice Basics. And this representation contents are what is what is Spice meaning, and second, what can we do by using Spice softwares. The third one, what kind of components can we use. The fourth one, steps involved in simulating a circuit, and the fifth one, the values of elements can be specified using scaling factors, upper or lower case. Okay, welcome again, and let's begin. Okay, the first one. What is Spice meaning? Spice is a powerful general-purpose analog and mixed-mode circuit simulator that is used to verify circuit designs and to predict the circuit behavior. And this is of particular importance for integrated circuits. It was for this reason that Spice was originally developed at the Electronics Research Laboratory of the University of California, Berkeley, 1975. And the name implies that simulation program for integrated circuit in phases. This is the explanation of SPICE, and it was the meaning of SPICE. Okay, let's continue. Second, what can we do by using SPICE softwares? Okay, SPICE can do several types of circuit analysis, and here are the most important ones. Nonlinear DC analysis, as calculates the DC transfer curve, nonlinear transit and Fourier analysis, and calculates the voltage and current as a function of time when a large signal is applied. Fourier analysis gives the frequency spectrum, and also linear AC analysis calculates the output as a function of frequency. A Bode plot is generated, and also noise analysis, parametric analysis, and Monte Carlo analysis. Okay. In addition, Pspice has analog and digital libraries of standard components such as NAND, NOR, flip-flops, multiplexers, FPGAs, and PLDs, and many more digital components. This makes it a useful tool for a wide range of analog and digital applications. Also, FYI, all analysis can be done at different temperatures. The default temperature is 300 Kelvin. Okay, let's move on to the third one. Third, what kind of components can we use? The circuit can contain the following components: independent and dependent voltage and current sources, resistors, capacitors, inductors, mutual inductors, transmission lines, operational amplifiers, switches, diodes, bipolar transistors, and MOSFET transistors, junction field affected transistors, and MOSFETs, digital gates, and other components. If you want to know more about, see user's manual. Okay, let's move on to the fourth one. Okay, we will use this configuration in our methodology. Steps involved in simulating a circuit. Step 1. Circuit creation with capture. Create a new analog mixed AD project and place circuit parts, connect the parts, specify values and names. The second step is that specify type of simulation. Create a simulation profile. Select type of analysis, BIOS, DC sweep, transient, AC sweep analysis. It doesn't matter. You should select one of them and run Pspice. And the last step is that view the results. To view the results, you should add some traces to the probe window and use cursors to analyze waveforms and check the output file if needed and save or print the results. And that's it. This is our methodology. We will follow these steps in our projects. Okay, let's move on to the fifth one. The fifth one says that the values of elements can be specified using scaling factors, upper or lower case. Okay, the values of elements can be specified using scaling factors, and T or tera represents that e to the power 12, and G or giga it represents that e to the power 9. Meg or mega, it represents that e to the power 6. Chi or kilo, it represents e to the power 3. And let's move on to the small values. U or micro, it represents that e to the power minus 6. N or nano, it represents that e to the minus power 9. And P or pico, it represents that e to the power minus 12. F or femto, it represents that e to the power minus 15. You should use these scaling factors. If you use another kind of ladder, you will have some errors in your project. Okay, both upper and lower case letters are allowed in Pspice and Hspice. As an example, one can specify a capacitor of 225 picofarads in the following ways. If you have a 225 picofarad capacitor, you should write like that. Example given: 225 P, a big letter P, 225 P, low letter, lowercase, and 225 PF picofarad, and 225 picofarads, and 225 e to the power minus 12, or 0.225 nano. And that's it. You should use those factors, those scaling factors, okay, to give values to your elements. Okay, and that was also there is another note for you guys. Notice that mega is written as meg. Example given: a 15 mega ohm resistor can be specified as 15 meg, or 15 meg ohm, or 15 meg, or 15 e to the power 6. Be careful not to use m for mega. When you write 15 m ohm or 15 m, Spice will read this as 15 milliohm. I am warning you guys again and again. Please be careful about this. Okay, that was thank you for watching this video. If you like this presentation, share it with your friends, and see you soon in the next video. Also, and this was the last theoretical video about Pspice tutorials, and then in the next videos I will record some projects, some analysis, bias or DC analysis, DC sweep simulation circuits. Okay, thank you very much for today. See you.